Hello and welcome to topic 7 of the Year 12 Software Design and Development course, Maintaining Software Solutions. Maintenance is an ongoing process of correction and refinement. When we used to build software back in the day, back when we were kept in the basement and we wore socks and sandals, we used to expect software to last 10, 15, or 20 years. And as such, we would be constantly working on software. We'd be constantly iterating over things, fixing things, modifying things, and adding features to software. This has changed rather significantly in the last 10 odd years. Now, software iterates very quickly. Software is replaced really quickly. Not at a sort of corporate level, like if you're building for a bank or if you're building for an insurance company or something like that, that still has a very long lifespan. But in terms of building software for the mobile market or for the gaming market or things like that, the life of software has decreased dramatically. Now, why do we maintain software? Well, we need to fix bugs, all the nasty little things that make software miserable, and also upgrade and enhance the functionality of our software. No software is ever built exactly how they expect it to be finished. You will often, and you will have done this yourself in your projects, gone, I really wish I could have added this, or if I could add that, that would be great, and I want to add this, 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 and this. Well, you just can't. The thing is, all developers think like that. All users think like that. And so those added features that they want to see, those go into, oh, we'll do that in version 2. We'll do that for version 3. We'll add that to version 3.5. So upgrades to enhance functionality are always known. They're always in the sort of the back of the mind of the developer. If you have a particular piece of software that you really enjoy using, you'll probably actually even find a roadmap for that software where they talk about features they're going to add in the future. These are well mapped out and planned for. The biggest reason to do lots of modifications is to meet changing requirements. Software solutions are never static. They evolve over time. And the reasons for a change could include bug fixes, so something's just not working. New hardware has been introduced, and that often changes how software might run. New software purchases that they're hoping to use with the software that you've already built. Operating systems change, and that is actually more and more a massive issue for developers. As new operating systems are released, software stops working. It is a misery, particularly if you're building software in the Mac environment. Every single year, it seems like software is being broken by upgrades to the operating system. And laws and regulation. Now, that one often people get surprised by. How would law or regulations change how software is, used, or how does it encourage changes? Well, before your time, in the year 2000, Australia adopted the GST. Previous to that, we didn't have a GST. We did not have a goods and sales tax in the way that we actually do now, where a flat 10% was going to be applied to goods that you purchased. At the time, if you were running any kind of invoicing software, any kind of accountancy software, banking software, anything like that, everything had to be upgraded. Everything had to be changed. It was a massive deal. And lawsuits relating to that have only been settled in the last few years. 15, 16, 17 years after the changes were required, people were still in court over the changes to software that were required for it. It was a massive deal. And if you think about some of the other changes in terms of privacy advocacy, data portability and things like that, where laws and regulations can actually change how software is allowed to maintain your information or keep your information, things like that. Customized software written for a particular client, so if you've built it for a customer, will require constant modifications. They will always have a long laundry list of things that they want to improve, things that they want to do, or things that they maybe didn't quite explain to you quite correctly, so it will need to be changed. Scripts that are used in these systems are a list of commands that can be executed without user interaction. And these ones are often changed to allow for a different environment to be changed or a different set of data to be utilized. Macros are not something that's used that often anymore. Still in the syllabus. A macro is a saved shortcut in your software. We used to develop a lot of macros back in the day for Microsoft Office products, where you would create a long series of manipulations to a document that was essentially just run off a short key or a button on a menu or something like that. It's actually really powerful. And a little known fact these days is that every single version of Microsoft Office, whether it's Excel or Word or PowerPoint, actually has a fully embedded programming language built into it, Visual Basic, where you can build exceedingly complicated and sophisticated automations to your software, to your document management. It's incredibly powerful and highly underutilized, I believe. So when we come to actually make some changes, the location of the section to be altered is really important. Documentation assists here. We have our structure charts, we have our DFDs, we have our flow charts, we have all of these things. The documentation allows us to identify where changes need to be made. This is really important because you don't want to go around guessing where something needs to be changed. If you think about it, you don't want to be changing a module here. You don't if you don't need to, because the side effects could be somewhat dramatic. You also need to determine the changes that need to be made. These changes to one module will almost certainly affect another module, and this needs to be considered and carefully tested. If you get this wrong, it's very, very bad. Once you've actually made all of the modifications, you need to implement this. And this will have a ripple effect on all other aspects of the system. So if we think about our software development cycle, this is very similar to the software development cycle. We define what needs to be changed. We plan the changes, we build the changes, we test the changes, and we modify the changes. So this is just part of an ongoing waterfall cycle of development. You need to be very careful when implementing modifications that the ongoing side effects don't actually disrupt business too much. One of the ways that we can do this is to document the changes. As I've mentioned previously in class, the people maintaining software are very rarely the people who wrote it. And as such, documentation is extremely important. If we don't know what we are working with, it makes it much harder for us to actually make effective changes. Being able to go through old algorithms and the flowcharts, the diagrams and everything else, help us understand the code that we're inheriting. Often we'll disagree with how things are done, but as long as we understand how they're being done, it actually helps us make those changes. When we're actually going around changing those bits of software, we need to document it for the developers who are going to inherit our changes. So as modifications are made, they need to be tracked and fully documented. Original documentation needs to be modified to reflect the changes. You can't have old documentation piling up with new documentation without it being clearly delineated what is what. We often use case tools now to make this easier for us. Git is a big tool that's used for management of this. We should all be using Git by now. But using case tools or computer-aided software engineering tools, we can help maintain the data integrity, the traceability of changes, and the accountability of changes. Once we've actually made all of these changes, we also need to update the documentation and online help for the users. They're going to be very, very confused if the changes are not clearly identified to them. And again, we can use case tools to assist with this. Change management, again, we use Git. Parallel development, which allows multiple users to concurrently work on the same thing. All of this is part, and version control is all part of the modern development environment. We've all pretty much universally gone to the Git method. We don't use Mercurial or, what was the other one? Subversive anymore. We're pretty much, in fact, even the big suppliers of version control, like Atlassian, are actually dropping support for those other development version control systems. You'll find that pretty much we're all just going to get one version or the other.